Hello, I'm Jamie. I'm a member of the CAL FIRE modeling team that developed the Fire Hazard Severity Zone map for California. Fire Hazard Severity Zone maps are built to describe relative wildland and urban interface fire hazard potential over the long term for all areas of the state. The zones reflect areas that have similar burn probabilities and fire behavior characteristics and are split into three classes: moderate, high, and very high. To explain the methods used in building fire hazard severity zones, we will show the sequence of steps and some key data inputs, zooming in on the north-central part of Butte County near the cities of Chico and Paradise as an example. The same steps were used statewide. Different steps were taken for modeling fire hazard severity zones in wildland areas and non-wildland areas. Wildland areas include places such as forests, grasslands, and shrublands where the land cover is dominated by vegetation. In these areas, we can apply well-established scientific methods to model fire behavior such as spread and intensity. The potential fire behavior is combined with the likelihood of fire to get an estimate of the hazard. Non-wildland areas include urban, agricultural, and barren lands, and water or wetlands. In these areas, hazard arises due to embers coming in from adjacent wildlands and associated fire spread through urban vegetation and structures. We estimate hazard in non-wildland based on the number of embers, where those embers are likely to land based on local wind patterns and the slope and tree cover within the area, which can increase the chance of fire ignition and spread. The first step in building fire hazard severity zone maps is to define the zones, areas of the map where fire hazard severity zone scores are determined and a classification is calculated. The zones aim to capture patches of similar fire behavior potential or fire environments. Fire hazard severity zone classes are ultimately applied across an entire zone. The data inputs for developing the zone boundaries include slope and vegetation. Areas that have similar slope and flammability are aggregated or grouped into zones. There is no maximum zone size, but there is a minimum size of 200 acres for continuous wildlands and smaller for islands of wildlands surrounded by urban and agricultural lands. The fire hazard severity model for wildland fire has two key elements: probability of an area burning and expected fire behavior under extreme fuel and weather conditions. The probability of an area burning was calculated using fire history for the years 1991 to 2020. Knowing how much area burned within broadly similar areas of vegetation and climate allows us to calculate the annual likelihood of a fire occurring in that area. We then estimate the potential flame length if fire were to occur based on vegetation type, slope, and the local climate. Vegetation type and climate allow us to understand how much fuel may be present and how dry or available to burn it may be. Because fire hazard severity zones are intended to measure the potential hazard across multiple decades, we use a long-term look at fuel development and do not adjust our data inputs to account for recent fires or fuel management activities. We want to know what a fire could be like under the worst fuel conditions that may occur in an area. Similarly, for climate data, we use the worst 5% of fire weather observations that occurred on days when the weather is dry enough to carry fire. This allows us to capture areas that have infrequent but regular occurrences of hot, dry, and windy conditions and include that in our estimate of hazard. We then combine the probability of fire with the potential flame length to get a final score for hazard in wildland areas. All the scores within a zone are averaged to get a final value for that zone, and the zones are summarized into final classes of moderate, high, or very high. The first step in estimating hazard in non-wildlands is to model ember transport out of adjacent wildlands. Remember that non-wildlands include urban, agricultural, and barren lands, and water or wetlands, and that the hazard in these areas comes from adjacent wildland. To model embers falling onto these lands, we must consider how many may be produced and where they are likely to land in the event of a wildfire. The number of embers, also known as firebrands, produced in the wildland is a function of vegetation type, modeled flame length, and burn probability. We model the dispersal of embers into non-wildland areas under the worst local fire weather conditions when fires are more likely to challenge containment efforts. For example, if the worst fire weather at a given location tends to have winds predominantly out of the northeast at 40 miles per hour, modeled firebrands go predominantly to the southwest and go a greater maximum distance than they would at a site with predominantly 20 mile per hour winds. We then add up all the embers coming into the non-wildland to get an estimate of the relative number or brand load landing in a given location. We build fire hazard severity zones in non-wildland areas by generating buffers off any adjacent wildland. The initial zone classification is the same as the adjacent wildland, with buffers of lower fire hazard severity zone classes modeled at further distances from the wildland boundary. In addition to brand load, we include slope and tree cover in generating fire hazard severity zone buffers, as these factors can promote greater fire ignition and spread. The width of the fire hazard severity zone buffer is wider in areas that have higher brand load, steeper slope, and greater tree cover. In non-wildland, areas that are sufficiently far from hazardous wildlands can remain unzoned, in contrast to wildland areas, which always receive a zone designation. This completes the modeling process for fire hazard severity zones across all lands in the state. Once we have a final fire hazard severity zone map for all lands, the final step in map development is to extract state responsibility areas to fulfill the requirements of the regulatory process. If you have further questions on the zoning methods, please visit the Fire Hazard Severity Zone website for more information on the model and the project in general.